All right, as you said, good morning. We'll start the webinar now. Thank you for joining us today. The topic of our webinar is how to assess a published peer-reviewed statistical research study. I'm William Bannon of StatsWhisper. Feel free to visit us on the web at statswhisper.com. Okay, introductions. So the goal of StatsWhisper is to make statistical research methods more understandable, usable, and rewarding. Is this possible? Yes, and you don't need to be a rocket scientist to do so. So take me, for example. Thank you. My original plan was actually to be a clinician, and I actually just took a liking to these materials and developed some proficiency in them. And I'm here to tell you that you can too. Okay, so it all started in my sophomore year, where I got a program called Where There's a Will, There's an A. And it presented academic success as a series of steps like this. So there was a stepwise approach to accomplishing anything in academics successfully. Right? So I developed the 7 steps of data analysis as a hybrid of that almost, to help other people approach data analysis kind of in a logical way that would ensure their academic success as data analysts, researchers, students, academics. So today what we'll be doing is applying the 7 steps of data analysis approach toward assessing a published research study. So we'll discuss peer-reviewed statistical research articles and how the 7 steps of data analysis model can be used to assess specifically the quality of the research article. Right? So then later on, we'll discuss more resources for becoming more familiar with the 7 steps model and the details therein. So our point of interest today, the peer-reviewed scholarly article. Right, so for those who are not familiar, the peer-reviewed scholarly article are reviewed by experts in the field, or at least by peers in the field. Right? You don't know who the author is. So when they review, they don't know who the author is. And that's supposed to encourage the article actually succeeding or failing on their own merit. So the reviewer could be reading, the top expert in the field, or, somebody just submitting their first research article, right? So the thought is there's no bias, right? So when I first learned of peer-reviewed research articles was when I got into my master's program, and I thought it was pretty exciting, right? The whole premise of being able to get a journal article and read the latest findings in the field, right? So you're informed, you're scientifically informed, right? So you not only know about the latest findings, but you can actually look at the research, right? Something you can't really see when you read regular magazine articles and newspaper articles. You don't really see the research behind the findings. But with the peer-reviewed journal articles, right, you could see the findings and you could see how the findings were arrived at, right? So your actions in the field could be evidence-based, right? So up to then, I had many jobs, right? I never knew if what I was doing was the best way to do what I was doing, right? So this was exciting because then you could say, oh, well, I'm doing this because this peer-reviewed research article presented evidence that said this is the most effective way to do it. So this was very enticing to me, right? So and you could be on the cutting edge. So if you kept reading, not only did you know, but you could know the absolute latest research going on, and be right at the cutting edge. So this all sounded tremendous to me. And so It represented a great deal of promise. But here's the catch, and this is what we're going to be going over today. The catch was that the articles ranged in quality, and this was something I didn't know, for a while, right? Pick up a research journal, and you read the article, and you figure, as many people do, if it's published in the journal, it must be, valid, at least valid enough to believe the findings. And why would you believe one journal and not another journal, right? So it just seemed that it should all be equal, but that was the catch. The articles ranged in quality, and the journals also, the articles published within the journals, were more or less rigorous than one another, right? So some articles were really excellent and covered all the bases, and some didn't. But you don't really know this right off. So it took some learning to figure out how do you tell, right? How do you tell which are the excellent ones, the very good, the average, right? So what I realized is there's no actual universally accepted method for testing the quality of the journal articles, right? So there's not a set of standards that could be applied to an article that if the article met them, you would say, yes, this article covers the bases. And if the article didn't meet them, you would say, well, this was strong, that was not so strong, right? If you think about it, in most fields and in most topics, there are often ways to judge, right? Like if a doctor's looking at a wound, he knows, certain qualities of the wound, and, he could judge the severity, right? Or she could judge the severity of the wound. But for a journal article, especially a scientific statistical journal article, there's no real criteria to apply. So that's what we're covering today. So yes, this is what I looked like for a while. So you wonder about the quality of the article, right? Are the statistics sound? And then, of course, related to that, are the findings credible? This is actually a real kind of painful place to be, this whole sense of ambiguity, where you're not really sure. It's like if someone took you to an art show and they show you a painting, and you're not really, it sort of looks good, but you don't really know, right? That's a horrible place to be. You want to be informed, and you want to have criteria to apply. So specifically, we need a method to systematically assess the article, especially the soundness of the statistical methods, which is our focus today. Many times, now the statistical methods are like the centerpiece. I mean, if it's a quantitative research article, right? Quantitative it's the first word. It gives it away. The statistics are the centerpiece of that research article. Now, often the literature review is like wonderful, and the conclusion is logical, and it's well written, and there's a well thought out argument, right? But the statistics, right? The statistics might be a little lacking. Well, if the centerpiece, if what's supporting the whole article is lacking, all those other great qualities surrounding it might be for naught, right? So you don't want to be drawn in, right? Drawn in by the pretty stuff around the statistics that look great, right? Because the statistics have to be sound. And if they're not sound, everything else is kind of based on something that's not sound. So the key is having predetermined criteria. Right? You need to know what should be in that quantitative research article before you even pick up the quantitative research article. And if you can do that, then you're in a great place, right? So the same with that art show. If you know that if there's a painting of a bowl of fruit and the banana shouldn't be through the apple and things like that, right? So you know, before you even look at that research article, it should have A, B, and C. That's the key. Because what's done is the article is picked up and read without any criteria in mind before it's read. That's why after it's read, it looks good. But if there's anything lacking, you wouldn't know it because you didn't know what should be there before you read it. So the missing fundamentals, if you don't know what should be there, huge fundamentals could be missing and it wouldn't be a concern at all. However, if you know the fundamentals that should be there and they're not there when you read the article, you know to be concerned. If you want to be philosophical about this, right, let's take archery as an example. If you're an archer and you look at this photo, it looks kind of strange because, you know, the bow is missing. So if you're an archer, you need a bow and an arrow. And so you can see here the bow is missing and the arrow is just hanging in the air. Right? But if you're not an archer and you've never seen archery, the picture might look quite normal. You know, they're just sort of pointing downfield. What are they pointing at? We don't know. That's why it doesn't look so awkward. Right? So the archer knows before he looks at photos of people performing archery that there should be a bow and an arrow. So here, 50% of the essentials are missing. The archer can see that right away. But if you're not an archer, you've never seen archery, never heard of archery, 50% of the essentials are missing, but you might not even realize anything's missing. And it's the exact same way with the peer-reviewed research article. Right? Huge fundamentals could be missing, but if you don't know what should be there before you read it, you wouldn't notice that. So like I said, so we're going to go through the 7 steps of data analysis that cover the essential 7 steps, the fundamental 7 steps that should be followed in any quantitative research article. Not only should be followed, but should be expressed, you know, in the report, right? The peer-reviewed research article or research report. So research would tell the experience would tell the researcher, right? The researcher doesn't tell experience, that all 7 steps should be present and accounted for prior to reading the article. So we're going to go over these really fast. Well, not really fast, but not really slow either. Right? So we're going to go over the steps, then we'll go over them a little more in detail, then we'll apply them to one of the first research articles I did. And why? Because I don't want to really criticize anyone else's work. And this article has kind of some of the common mistakes that are made you know, when publishing a peer-reviewed article. So I avoid, you know, pointing out anyone else's mistakes. And, you know, there's plenty of mistakes to focus on. So what else can you ask for? Okay, so the 7 steps of data analysis. You know, step 1, we have our study map, right, where we just map out the variable relationships. Right, so what's the independent variable, the dependent variable. Right. Step 2, data entry, because you need to enter the data into the database before you could do the analysis. Now step 3, this is one we're really going to harp on, because this is perhaps the most important step, and it's also the most skipped over step and most neglected step in data analysis. So step 3, I like to refer to as a man's shoes, right? Because whenever you wear a suit, like if you're going on a job interview, they say that the first thing the interviewer looks at is the man's shoes, because that's the last thing a man getting ready for a job pays attention to, right? So if the shoes are shiny and done up, chances are everything else is in order, right? So if you're reading a peer-reviewed research article, if this step 3, the checks of data integrity, are done correctly and presented correctly, the chances are real good that everything else is presented really well too. And then step 4, univariate analysis, also referred to as descriptive analysis, where you present the qualities of the variables, the mean, standard deviation, the percentage in each category, all that sort of thing. Bivariate analysis, where you're looking at the one-on-one relationship between variables. Multivariate analysis, and the write-up and report. So we're going to go over these a little more in detail and then apply them to that research article. So before we get off this, so this is every single quantitative study, whether you're performing it or reading it, should have all this clearly mapped out, clearly laid out. Right? So these are the criteria to keep in mind before you pick up that quantitative research study. Right? So for the sake of brevity, we're only going to focus upon the big question posed within each step. Right? If you ever attended the webinars here before, I'm fond of saying that a little bit of something, right, is better than a lot of nothing. Right? So if we try to cover too much, chances are, learning might not occur. So we're going to just cover the essentials and try to get that learning in. So step one, the study map. Now, this may look kind of simple, right? Just mapping out the relationship between the variables. But many times, when you read a published quantitative study, you might find that if you try to actually do this based on the information presented in the study, you can't make it out, right? You might not be able to clearly say, this is the dependent variable, right? So in our study map here to the right, we see under dependent variable happiness. So happiness is what we're studying, what we're trying to explain, right? And on the left, we have our predictor variables, right? Our independent variable and covariate variables, the predictors. So does education level predict happiness? Does income level predict happiness? Or does living with a dog or cat predict happiness? Right? So we could clearly see, like a picture is worth 1,000 words, right? We clearly see in this picture exactly what the whole study is examining. This is really important because, the old saying is clarity is power. So we want to make it really clear what we're examining. Because sometimes when we start talking about the results and the statistics, all clarity fades away. So it's good to have a nice clear image of what you're examining or what's being examined or what you're reading about before you even start. So this, per se, is the topic of the study. Now, step two, data entry. Most people, when they hear data entry, they just think of this. Right? So on the left, you'll see it says the study survey. Right? So ID, demographic questions like your highest education level. And this person circled high school, and their ID is 1. Then on the right, you see it's entered into the SPSS database, right? So ID 1, education, high school is coded as 1, so in the database it's 1, right? When people hear data entry, this is the first thing they think about, and validly so because it's a big part of it. But as you can see up above, the big question is, are the data entered / prepared correctly? So this is entered correctly, is this part, but there's also various forms of data preparation involved in data entry. Just to mention a few. Right, so coding the data, right, the data dictionary. Like in the last slide, you saw education, high school was coded as 1. Right, so that has to be written down somewhere. Right, so how the survey has been coded to be reflected in the database, that needs to be written down somewhere, so you make a data dictionary. So you could simply just take the survey and write next to education level, either type or if you're doing it manually, write in, high school equals 1, college equals 2, right? So that's the data dictionary. So it's a written record of the names of the survey items how they're reflected in the database. And then, of course, there's creating the database. So we looked at entering the data in the database, but before you do that, you have to create the database, entering the data, we saw. And then if you have to recode data or compute the scales, you could do that here. So computing the scales is if you have, a scale of 10 items, sometimes all 10 items are added up to, measure one construct. Right? So are you happy? Are you unhappy? And they're all added up to reflect, a global score of happiness. Now here's the checks of data integrity. So as I said, this is a point we're really going to focus on here. So, are the data entered appropriately for analysis? Now the reason this is skipped over so often, even though as I said it's probably the most important step, because if you don't have appropriate data for the analysis, the entire analysis might be off. Like all the findings, all the conclusions, everything. So the statistical analysis could even be done, steps 4 through 6 could be done perfectly. But if the data aren't appropriate for the analysis, as we're looking at in step 3, none of that matters. So, are the data appropriate for analysis? So these are the 4 areas that I like to refer to as, where checks of data integrity need to be made. These aren't commonly accepted, rules in the field. This is just my interpretation of the 4 necessary areas where data integrity should be checked. So first is statistical power. Do we have the right sample size? Right? Second, test assumptions, and we're using multiple linear regression. That there's a bunch of them. One of the most influential is examining the influence of outliers, right? Missing data. So that refers to, how much data are missing. Is there any patterns to the missingness? And then how did we treat the missing data? And then the measurement tools. How we assess reliability, validity. Because don't forget, if the variables aren't being measured correctly, then the study is not really examining what the study claims to be looking at, right? So if I say, I'm looking at depression, how are you measuring that? And I say, by how much ice cream someone eats in a week. Because I know a lot of people that say, when they're depressed, they eat ice cream, right? Well, the title of that study is still going to be, what affects depression, right? It's just that depression is going to be measured in a way that might not be applicable, right, to everybody in the world. And so that's important. So univariate analysis, right? So here's the sort of getting to know you phase of the variables, right? So what is each variable like on an individual basis? So there's different expressions of this depending on if the variables are continuous or categorical. So if the variable is continuous, such as our happiness, right, maybe it's measured on a scale of 1 to 5, and then we look at, if we have 100 study participants, what's the mean score, right? So we say the mean score is 3.5, right in the middle. So the average person was, not terribly happy, not terribly upset, right? And then if it's a categorical variable, such as gender, living with a dog or a cat, we might present the numbers in raw percentages, such as how many people live with a dog? 33, which is 33%, and live with a cat, 77, which is 77%. Right, so now I want you to pay attention as we look at these 3 phases of data analysis, the univariate, bivariate, multivariate. It's like 3 separate dimensions. You can't see this dimension of what's each individual variable like, within the other dimensions, the bivariate, multivariate. So if all 3 are not presented in a peer-reviewed research article, you just can't see it. It's like a hidden dimension. And all three are very important dimensions. So if this isn't reflected there, that might be a cause for alarm. For example, if we're looking at happiness, and there's a 1 to 5 scale, and the mean score is 4.8, right? 1 to 5, 5 being the most happiness, and the mean score is 4.8. Well, it looks like most of the sample is just extremely happy, and that has implications because we're trying to see what predicts happiness. But if the whole sample is just as happy as can be, that's going to be difficult. The same thing if it's 1.2, where nobody's happy. But if we're looking at the descriptive statistics, the univariate statistics, and the average person gets a 3.5, well, it looks like the average person is right in the middle, and there's probably really happy and really unhappy people, and people right in the center. So often, actually, in a peer-reviewed research article, you'll see the descriptives are left out, and you can't see that dimension. And of course, that impacts all the other dimensions. So it's important that it's portrayed. Now, the same with the bivariate analysis. The bivariate analysis is also left out of many articles. So many articles, you'll see they might present the descriptives, right? So let's say the average person is this happy, and then it jumps right into, like a regression model, the step 6, the multivariate analysis, right? So it jumps right into a regression model and shows how all the predictors jointly affect happiness. Well, what's the trouble there? You can't see how each predictor one-on-one impacts happiness. Sometimes when you look at the joint effects, right, it looks like none of them are significantly related to happiness in step 6, but at the bivariate level, maybe each on a one-on-one level was significantly related to happiness, but you can't see that unless the bivariate statistics are presented. And this will be clearer when we go over the research article. So the multivariate analysis, the big question here, what's the strongest variable relationship? So the bivariate might have said, on a one-on-one basis, education is significantly related to happiness. Income level, right, one-on-one, is significantly related to happiness. Right? One-on-one, living with a dog or a cat, is significantly related to happiness. Right? So that, but then when we get to step 6, if we put them all in a regression model, often one will be significantly related to happiness, say living with a dog or a cat, but all of a sudden the other two are no longer significantly related to happiness. Right? So we might say there that living with a dog or a cat predicts happiness above and beyond, the other two predictors. Right? But if that was all that was presented, right, that joint effect, you couldn't see that at the bivariate level there were significant relationships. Right? So that's what I mean. It's like 3 different dimensions. And if any one of them are left out of the article, then something's amiss. Right? So like I said, 4, 5, and 6, variables in 3D, right? 3 dimensions. So step 4, we describe the variables individually. Step 5, we describe the significant one-on-one relationships. And step 6, we describe the strongest relationship between, say, a dependent variable and a predictor. Right? So before you pick up a quantitative research article, again, this is a little repetitious, right? So before you pick up a quantitative research article to read, you should expect that all 3 dimensions are going to be reported between, among the variables and between the variables. And then there's the write-up and report, right? So as I say here, it's a whole other can of worms. So the analysis is often involved, right? And then you breathe a sigh of relief. But then the write-up and report is actually a whole nother involved process beyond that, right? Fortunately, there are many guidelines like the APA and AMA format that you can follow that will tell you how to comprehensively, write up an article. One of the best ways is to find a series of articles that you like the way they're written and they're written comprehensively. And then perhaps, observe them as templates, as examples of how you might structure your article. That's what I did early on. So, it's tutoring. It's very valuable. So, apply, apply, apply. Here's where we will apply the 7 steps of data analysis to an actual article. Okay? So we're going to look at one of the first ones I wrote. I actually wrote it the week I learned regression. So obviously it uses multiple linear regression because that's what I learned that week. So the name of the article is, Are Barriers to Service and Parental Preference Match to Service Related to Urban Child Mental Health Use? So the question was, and is now, I guess, if a parent wanted certain services for their child mental health services, and got them, right, match for service, right, they got what they wanted service-wise for their child, is that a stronger predictor of them coming in and using mental health services relative to reported barriers, such as, transportation, concrete barriers, doubt barriers, that sort of thing. So if they got what they wanted for their child, did that predict them coming to services more than barriers they reported? So that was the premise of the article. And so that's clear. Now we have to translate that into statistics, and then after that we have to assess, was it translated into statistics at a sufficient level where we have confidence in the findings and the methods. And so the big if-then. So if each of the 7 steps are described and completed effectively within a study, then we can regard that published study as high-quality research, per se. Of course, the statement doesn't fit all research, but per se. And of course, I mentioned this later, usually it's not, black and white. Usually it's not every single little thing was followed, in each article, but the thing is it really wouldn't be practical to reject every single article in the field, right, because that's all we have to work with. So we can't throw out everything. So we have to figure out just how well were these steps followed, right? Is it a sufficient level to where we would call the article credible? So the study map, like I said, so if you have an article and it's clearly written out, you should be able to draw a study map and figure out what's being examined, right? So what we have here is the big question, what are the variable relationships being examined? So the predictors are barriers to mental health service use and parental preference match for service. And how does that predict child mental health service use? So that part seems clear. So yeah, now here's kind of an interesting development, right? The data preparation and entry are not mentioned in many articles, even though, if the data is not entered properly, then the whole study is a bust, right? But they're just commonly not mentioned, so we're sort of led to assume that this process was done correctly. So we can't really, disparage any studies for not mentioning it because it's just commonly not mentioned. So let's just move on to the next step. Right, so our checks of data integrity. So we went over these before, right? So now let's apply them to our article. Statistical power. So when people talk about statistical power, what they're often talking about is, do you have enough study participants in your study, to make it, to be appropriate, right? If we only had 4 or 5 people in this study, that would seem kind of small, but 4,000 or 5,000 seems bigger than we need. So what's the right number? So that's a matter of statistical power. So if we don't have enough people within the study, right, if we only have 4 or 5, and there's no significant relationship between, say, the independent variable match for service and service use, we might be tempted to say, well, we did our study and there's no relationship between the dependent variable and independent variable, when really there might be, but we just don't have enough study participants to detect that relationship. So you'll see in many studies they report, power analysis was done, and it said we would need 100 people to pick up a small effect, between the 2 variables. And then that's fine. Then you know that if there is or is not a relationship indicated, that it's less likely to be because there was a lack of statistical power. It might be more related to the variables themselves. So that's important. Now, the test assumptions. So if you ever reference this article, and it's only 3 or 4 pages long, it's kind of a short report more than an article, but you'll notice the test assumptions weren't really addressed that well. Right? So multicollinearity was reported. That's the correlation between predictors. But the other assumptions related to, multiple linear regression of normality and homoscedasticity and linearity and outliers were not reported. So that really casts doubt on all the conclusions made. And what's rough is the conclusions are actually logical. So logic supports the results, but then the trouble is statistics-wise, there's a big hole. For example, right? So you might make a little checklist. So if you're looking at an article and it uses multiple linear regression, you could keep in mind, okay, before I read this article, the author should report on normality, multicollinearity, homoscedasticity, linearity, and outliers, and make it almost like a checklist style where these all reported, because any one of them could result in skewed findings, which distorted findings or findings that are just plain wrong, right? So any one of them, never mind 3 or 4 of them. So one mischeck can misrepresent all the findings, right? So we're going to illustrate this by looking at a t-test and just adding a few outliers to the findings. So let's say, right, that in our original example, that we're looking at the research question, the people living with dogs have a higher mean happiness score compared to people living with cats. So we want to figure this out. So first we do a t-test. Now this t-test, all the same checks of data integrity in terms of like outliers and normality were all assessed. So this is kind of the original valid t-test findings. So we see here that on the dog line, the top line, happiness dog, there's 47. So 47 people live with a dog, and their mean happiness score is 3.02 on that 1 to 5 happiness scale. People that live with a cat, there's 53, and their mean score is 2.48. Then if we look at the bottom right, we can see under SIG, right? So if it's 0.05 or below, the probability, that's what's listed under the SIG, then it's a statistically significant difference, right? And we can see here it's way below 0.05. It's 0.00. So what it leads us to what it indicates is that there's a statistically significant difference in happiness scores between people that live with a dog or a cat, where people that live with a dog have a significantly higher happiness score. And so that's the valid finding that was put through the rigorous check of test assumptions. But if we just add 3 outliers to each group, right, 3 low scores, 3 low happiness scores of 1.0 to the dog group and 3 high happiness scores of 5.0 to the cat group, all of a sudden the means, now instead of 3.02, the mean for the people that live with a dog is 2.9 and live with a cat is 2.61. Right? So it's closer, but more to the fact, the significance now, instead of 0.000, is above 0.05, so it's 0.09. So what it's saying now is there's not, right, so if you'd have done the second test first here, there's not a significant difference in happiness scores for people that live with a dog or a cat. So what's the point, right? So the point is if the researcher did that first analysis, or the second analysis, where the outliers were in there, it looks like there's no relationship. Then if the researcher failed to examine if there were outliers and what the influence of the outliers was, he or she might conclude that was the actual relationship, when it was a relationship that was incorrect and distorted based on a few outliers. But if you don't look for the effective outliers and check for that test assumption, you might believe the lie. And it seems somewhat innocuous because it's saying a significant relationship is not, but it can just as easily make a relationship that's not significant look significant. So many times in the literature, when in a peer-reviewed research article, you'll see the article says, here's a statistically significant relationship, and then doesn't mention if outlier scores were checked. So you don't know if that relationship is based upon the outlier scores or not. Right? And then missing data, which is a whole nother can of worms on top of the other can of worms, right? So first of all, you want to know how much data are missing, right? So, you know, if you have like 100 items and 100 study participants, is it just like 1 or 2 responses missing, or is it half the responses missing, right? There's a big difference. So you want to know how much data are missing, and then the other patterns to the missingness, like did the people who were living with cats, were they more likely to not report data or have missing data relative to the people living with dogs? And then finally, you know, how were the missing data treated? You know, were, you know, the mean scores of the valid responses entered, right? Or, you know, you know, or was there some like really far out sophisticated method like multiple imputation used to account for the missing data? Right? And are the measurement tools reliable and valid? Often we look at the Cronbach's alpha. That's the most commonly referred to metric. And often in a peer-reviewed article, the Cronbach's alpha should be 0.7 or above to be acceptable. And many times you might see it at 0.6 or 0.5, but the findings are described as valid, but the measurement with the Cronbach's alpha is too low to consider the measurement valid. Again, it's something you need to know before you look at it there, right? So as we were saying, we have to be sure the outliers were looked for and all the checks of data integrity were looked at, or it's going to skew the findings. Now, as I said, you know, to repeat, and it's repeated later, you know, the only thing checked for in that first article that I did, the one we're talking about, was a multicollinearity. So all the other things are big question marks about that study, which which is actually quite common. So like I said, it's a good study to review. So in the article, The univariate analysis actually is presented in Table 1 and Table 2, right? So if you ever reference that study, you can see they are presented, which is great. The bivariate analysis in the article, right, compares how the barriers related to service use, one-on-one, as well as how parental preference match for service related to service use, right? So those questions of significance were addressed. And then finally, the multiple linear regression indicated that the parental preference match for service was a stronger predictor of service use over and above the barriers. So you see, that's what I mean. You would kind of figure if somebody's getting what they wanted, they're more likely to say, well, I don't care about the barriers. I'm going to go because this is what I want, right? So like I said, the conclusion and the results are logical. The trouble is those missing checks of data integrity. So right, the big question of the strongest predictor of service use is answered. Right? So we have to have the conclusions regarding the overall quality of the article, right? So it's not black or white, like I said. It's not judgment of either good or bad, right? There's gradations, right? Because most studies have flaws. We gave a recent webinar where we looked at, like the top journals, like the New England Journal of Medicine and, real big ones, right? Rigorous ones, the most rigorous out there. And we looked at the quantitative articles, and most of the quantitative articles had either some or all of these checks of data integrity, skipped, right? So you couldn't be sure if the conclusions presented were based on statistics that the findings were skewed because the checks of data integrity had not been done. And like I said, these are the most rigorous and prestigious journals, right? So it all comes down to now the old saying of, I have some good news and I have some bad news, right? So the good news is, for example, in this article, that there wasn't at the time, and I still don't think there is, like an analysis that examines if service use is related to people getting the service they want. Which is kind of strange to say out loud, but that's the truth, right? Now the trouble is now the only study that addresses it, has some methodological limitations, right? So it's an understudied topic, right? And it's been cited a lot since it was published in 2005. So there was some value seen in the topic at least. So that's the good news. Steps 4, 5, and 6 were presented in the article pretty comprehensively. So that's more good news. Right? The bad news is that the checks of data integrity might produce, totally skewed findings, right? And like I said, this is a common problem. So what do? If it's a common problem, even in the big journals, it's not really practical to just regard all articles as not being valid, right? Because then you have nothing to work with. But then on the other hand, the findings might be off based on these checks of data integrity, right? So you got to take it all with a grain of salt. And as we illustrated with the outliers, right? Just that one check with the outliers totally, changed the conclusions of the research question. So if the checks of data integrity are not presented, there's no way of knowing if the results are or are not fundamentally wrong and misleading. Right, so yeah, just kind of saying it one more time. So when you read the articles, like I said, these are the shoes, right? These are the men's shoes. Look for the mentioning of statistical power, test assumptions, missing data, and measurement tools. Right? Then you'll be very far along in your assessment of the article. Because like I said, if the authors know enough to not only do these, but also mention that they were done and the results of them, then they're probably really sophisticated, and the rest of it, you know, I'm not saying to assume this, but the rest of it is probably pretty solid. But of course, to go through all of it. Right? So for more information, you can actually reference our current free statistical newsletter, available at statswhisperer.com/newsletter, which is titled "The Most Important Questions Not Being Asked in Statistical Research," which, you know, actually goes in more depth about what these checks of data integrity are and why it's so important to consider them. And it also goes into, you know, the use of a standard model like the 7 steps of data analysis and how that could support a more solid quantitative research base. And the references were the 7 steps of data analysis textbook published by us last year. Textbook is just written as a foundational understanding of statistical research, right? So you need to understand the steps, you know, so you could read the research article, you know, as we went through today, right? So you just go through those steps and say, you know, are they all reflected? Are they not reflected? And to what degree? And then if you know the steps yourself, you can follow the steps when conducting your own, you know, research study, be it a research study, a dissertation, capstone, you know, thesis, whatever. So you know the 7 steps, so you can follow them. So then when you're done, people can look back and you can look back and say, look, all these fundamentals were covered. Right, so yes, so you can go to the website, and I believe that on the book page, there's a PDF of the table of contents, which lists the 7 steps and kind of in more detail what's involved in each step. And that's at the statswhisperer.com. And then I was asked to mention this. I'm going to mention it very briefly, as we're almost out of time here. But there's also a 6-week webinar class, the Steps of Data Analysis webinar class. So it's based on the premise that by the yard it's hard, but by the inch is a cinch. Thank you. Right? So, you know, week by week, we just go over each step involved. You can look on the website if you're interested. I'm not really going to go into it that much. And, you know, the process, weekly webinars posted so people can watch whenever and watch them over. Q&A session, unlimited questions, a writer's workshop, and weekly chapters and an hour personal consultation just to help you fit your project to the materials. And you can look at that on our website at the webinars page. All right. Now, for more information, don't forget we have the newsletters archived, which means there's a whole bunch of old ones there, right? Oldies but goodies, right? They still refer to what's going on in the field, right? So check out the archived newsletters at statswhisperer.com/newsletter. And there's some archived webinars, the webinars page. There's actually an archived webinar for multiple linear regression and interaction effects that we just posted a couple of weeks ago. That's very interesting. And feel free to share all this with colleagues, friends, and students. And thank you very much for tuning in. All right, thank you, everybody.